Space weather. It's a term that might sound strange at first. We associate weather with Earth, rain, wind, snow. But space has its own kind of weather, far more powerful and potentially damaging. This weather originates from our sun. The sun is a giant churning ball of plasma, constantly spewing out charged particles and radiation. This constant stream is what we call the solar wind. Sometimes the sun unleashes more violent events. Solar flares are sudden bursts of energy. Coronal mass ejections, or CMEs, are massive eruptions of plasma. These events can disrupt our technology and even pose a threat to astronauts in space. Understanding space weather is crucial. By studying the sun, we can learn to predict these events and protect ourselves from their effects. Imagine a constant wind, blowing not from the Earth but from the sun. This is the solar wind, a stream of charged particles, mainly electrons and protons. It flows outward from the sun at speeds of about 1,000,000 miles per hour. The source of this wind lies in the sun's corona, the outermost layer of its atmosphere. The corona is incredibly hot, millions of degrees Celsius. This heat gives the particles in the corona enough energy to escape the sun's gravity. As the solar wind travels through space, it carries with it a magnetic field. This magnetic field interacts with the Earth's magnetic field, creating a dynamic and sometimes turbulent environment. The solar wind is always present. However, its strength can vary depending on the sun's activity. During periods of high activity, the solar wind can become much stronger, leading to more intense space weather events. Unlike the solar wind, which originates from our sun, cosmic rays come from far beyond our solar system. They are high-energy particles, mostly protons and atomic nuclei, that travel through space at nearly the speed of light. The origin of cosmic rays is still a mystery. Some scientists believe they are produced by supernova explosions, the violent deaths of massive stars. Others think they might come from active galactic nuclei, supermassive black holes at the centers of galaxies. These rays are constantly bombarding Earth. Luckily, our atmosphere acts as a shield, absorbing most of them before they reach the ground. However, some cosmic rays are so energetic that they can penetrate our atmosphere and pose a threat to satellites and astronauts in space. Section 4. Threats from the cosmos, satellites, and astronauts at risk. Space weather, while invisible to the naked eye, can have real and potentially dangerous consequences for our technology and human explorers in space. Satellites orbiting high above Earth are particularly vulnerable. The charged particles from solar flares and CMEs can damage sensitive electronics, disrupting communications, GPS navigation, and weather forecasting. Astronauts, too, face risks. Exposure to high levels of radiation from solar flares can be harmful to their health. During intense solar storms, astronauts on the International Space Station may need to take shelter in shielded parts of the station. Understanding and mitigating these risks is a top priority for space agencies around the world. By developing accurate space weather forecasts and designing more resilient spacecraft, we can better protect our assets and astronauts in space. Section 5. Predicting the solar storm, forecasting space weather. Just like meteorologists forecast the weather on Earth, space weather forecasters monitor the sun, looking for signs of potential storms. They use a variety of instruments, both on the ground and in space, to observe the sun. These instruments can detect solar flares, CMEs, and changes in the solar wind. One crucial instrument is the Solar and Heliospheric Observatory, also known as SOHO, a joint mission between NASA and the European Space Agency. SOHO constantly observes the sun, providing real-time data on its activity. By analyzing this data, forecasters can issue warnings of potential space weather events. These warnings allow satellite operators and space agencies to take steps to protect their assets. Section 6. Shielding our technology, protecting against the invisible threat. Protecting our technology from space weather requires a multi-pronged approach, combining advanced forecasting with innovative engineering solutions. One strategy is to design more radiation-hardened electronics for satellites. By using materials that are less susceptible to radiation damage, engineers can make satellites more resilient to the effects of space weather. Another approach is to develop better shielding technologies. For example, some satellites are equipped with magnetic shields that can deflect charged particles. For astronauts, special radiation shelters can be built into spacecraft or space stations. These shelters provide a safe haven during intense solar storms. The quest to understand and mitigate space weather continues. As we venture further into space, our reliance on technology vulnerable to these solar tantrums will only grow. By investing in research and developing new technologies, we can ensure a safer and more sustainable future for space exploration.